So for number 65, it's saying if $1,000 is invested at 6% interest compounded annually, then after n years, the investment is worth AN. So we have here that AN is equal to 1,000 times 1.06 to the power of n. And this makes sense because 1,000 is our initial amount, right? And this 1.06 to the power of n, this is what makes it grow. So we're growing by 6%, right? So every year, this is being raised to a power. It is growing, and then it's making that 1,000 get bigger. Okay, so then it's asking us, first, find the first 5 terms of this sequence. So A1 is equal to 1,000 times 1.06 to the power of 1, right, which is just 6%, and so this is going to give us 1,060. A2 is going to be equal to 1,000 times 1.06 to the power of 2, and that is going to give us, let's see, to the power of 2, that is going to give us 1,123.6. A3 is equal to 1,000 times 1.06 to the power of 3, which gives us, let's see, 1.06 to the power of 3, 1,191. A4 is equal to 1,000 times 1.06 to the power of 4, which is equal to, let's see, 1,262.5, and lastly A5 is equal to 1,000 times 1.06 to the power of 5, which is, let's see, 1,338.2. Okay, so we have our first 5 terms, right? And we can see that the value keeps increasing. It goes from, in the first year, you're going to get $1,060, and then 1,123, and so on. In the 5th year, you're going to get 1,338, and it just keeps increasing or increasing. And so we can say here that AN is divergent, right? And the reason that it is divergent is because of this guy right here. So when I'm taking this limit, I'm going to go the limit of AN as n goes to infinity of 1,000 times 1.06 to the power of n. It's like we're taking 1.06 and multiplying by itself infinite times, right? But this 1.06, it's greater than 1. So it means that when I multiply it over and over and over again, it's going to get bigger and bigger and bigger. Because this is a geometric sequence, right? A geometric is where I have a ratio to the power of n. And this 1,000, it just stays outside, that doesn't matter. But this is our geometric sequence. And so when the absolute value of r is greater than 1, we say that the AN diverges. So, and we can clearly see here, because this 1.06 is greater than 1, when we raise it, it keeps increasing and increasing. And so that is it for number 65.